Hello, I'm trying to explain and demonstrate how the BWT Run-Length FM Index is. Assume all of you already know how to make a original string from a original string to BWT string. So this method will be more advanced. So for example, if the BWT encoding strings is already given, as this one. So as we already know, the last column of the rotation should be the BWT string, same as this one. And we simply just sort this one and then make the first column. So from the last column, which is the same as the BWT string, if the characters here is the new character, and I'll make it as 1. If this character is consecutive with the previous one, then I'll make as a zero, mark as a 0. So that means whenever you see 1, there will be a new character. Whenever you see 0, that means this character should be the same as the previous one. So from last column and B column, we simply just because we sort this column and make and become the first column, so we simply just sort this one corresponding to this one. So sort this B and becomes the B prime. So this B corresponding to L, B prime corresponding to F. As you can see here, the B is a new character, so 1, new character 1, new character 1, because even though this is connected, but in the last column, it's not consecutive. So it should be 1 and 1, right? So as we all know that we can actually make it as a block. So for example, for the last column, I would like to create another column which is called S based on blocks. So as you can see here, 1 0 means those two E are at this in the same block, and those two H are in the same block, those two R are in the same block. So pretty much just put this character as a first block, second block, third block, and so on. And then our task is to calculate what LF2 is. So LF2 means if we have the last column and the first column, from the traditional method of looking, at decoding, you can just look for index 2. So LF means the index, the second index of the last column. E, what's the index of the first column corresponding to the index of the last column. So we know this is the second E in the last column, so we simply just look for the second E in the first column and refer back to the index. So we know that LF2 should be 7. What if we just given, what if only 3 columns are given, but get rid of the L and F? So how do we convert back to, how do we actually calculate this LF2? And first of all, we need to just, sort the S table. So the S table here, I simply just sort them and then to make another table which is called C column. And because we have BS and B prime, so now S indicates how many blocks in B, and then C indicates how many blocks in B prime. Most importantly, because they should be, they should be, this one correspond to this one correspond to this one. first block, second block, third block, fourth block, fifth block. E here should be sixth block here. This E should be the seventh block. So same as this one, so this is 1, the first block. This E should be this block. This D should be this block, right? I don't know why there's like an airplane whenever I, every time I do the recording, so I don't know. Sorry about that. Okay, so here are the key points of how to actually get the task done. And the first step is to find out, because we don't have L and F, so we don't know which characters we're talking about here. So what character do we need to decode? You'll find out, right? So the first step is to do the block number of B here. The block number of B here should be, because we have the second index here, so how many ones before the second index? Which is only 1. So we know that this should be the first block. So it should be the first block. So we already know that this actually represents how many blocks in B. So the first block should be E. So we know that the character we try to decode is E. The second step is to find the block number in B prime, because we already know that block number in B should be 1, right? And the block number in B prime here. So first of all, we need to know that how many characters are smaller than block the E in this C column. How many characters? Because we already know that character should be E, right? So the first E. So whenever I see E, I need to know how many blocks before that. Simply just count 1 block, 1, 2, 3, 4, 5 blocks before the E block. This is E block. It's not E, it's E block. So, but I would like to know there are in total of 2 E blocks here. I mean, in this example, there are 2 E blocks. There should be like maybe 1,000 of E blocks. You don't know that. But which E blocks are we talking about here? So we go to the S column. So we need to know how many E blocks have we seen in the S column with the position of block 1, right? So with the position of block 1 is here, so block 1 is here, so there's only 1 E here. So first E should be here. So how many E? There's only 1. So there's only 1 E block we see before the position of block 1. So let's just simply put 1 here. And then all we need to do just because we already calculated our 5 blocks smaller than E, so we just plus from 5 plus this 1 should be the block number of a B prime. 1, 2, 3, 4, 5, 6 should be here, this block. And now we know that the index of 2 is in block 1 of B column, and then block 6 in B prime column. And we need to find out what's the starting position of this B column. To find out what the starting position of this block, so that we can just calculate this distance later, and then plus this distance, we'll find out which E are we talking about, what exactly position are we talking about. The starting position of block 1 So in order to find out what is the starting position of block 1, we need to know what position of the first one in block 1. So apparently there should be 1. And how many ones here? So how many ones of the, like before this, should be only 1. And then in order to know that what the starting position of block 6 is, we need to know what is the 6th one in B prime. So how many ones in B prime before the 6th block? So 1, 2, 3, 4, 5, 6. So it should be 6 here. So this should be 1 here. How many ones are before and include block 1? So it should be only 1 here. And then after we know that, because we are trying to look for the index of, we try to calculate the distance from index 2 to the 1 here, the starting position, right? So we need to calculate distance, so that corresponding to this distance, they should be the same distance. So 2 minus 1, the distance should be 1 in block in column B. And then the position that we would like to find out, we simply just look for the column B prime, right? The block number here should be 6, and then plus the distance, which is calculated as 1. So 6 plus 1, 6, starting position of B prime, plus the distance should be 7. So the answer should be the same as we use LF mapping. So LF2 will be 7. That's it for today. Thank you for watching.